Okay, so if we're going to solve this integral, we're going to use integration by parts, okay? And we're going to use that DI method that we have been talking about. So versus the derivative column, this is the integral column, okay? And to set up our chart, and make the two columns, and we're also going to do the signs, right? Positive, negative, and make however many you want. All right, so when we choose which function we're going to differentiate, which function we're going to integrate, I do want to tell you about, there's this method to help you decide which one's which, or which one you should take. Now we know, because of previous examples here that we've done, that if you have some kind of like monomial like this, like just an x term with a coefficient or exponent, just a single term like that, that's the one you're going to want to differentiate. But there is a bit of a shortcut, and it's called the Liate method, Liate, okay? So this helps you to choose sort of which one you're going to differentiate first. So the L would be a logarithm, okay? Some kind of logarithmic function, so like natural logarithm or log whatever. And inverse function, okay? The inverse, if you have an inverse, and we haven't talked too much about inverses, but sine to the negative 1x and that sort of thing. Okay, and here's the algebraic, so like the monomial term, all right? And then a trig function if you've got a trig function, and then the exponential, so like the e to the power and so on. All right, so you're going to run through this list, and these are the ones you're probably going to choose first to differentiate. Okay? As you know, the exponential is really, really easy to integrate, right? So this is I down in this side, and this is the d kind of up here. So we run into, see there's algebra is ahead of trig. So that's why the algebra is going to be the one we're going to differentiate. Okay? So it's just a little guideline. All right, so as we go ahead and do this now, let's put the x squared here and the sine x here. And we'll go ahead and differentiate. Now, x squared, the derivative is 2x. The derivative of that is 2, and the derivative of that is 0. So here's where we stop. Okay, you've got 0, so all we need is 4 rows here in order to do this method, no problem. The antiderivative, the integral of sine x, okay, is negative cos x. You can refer to the chart from your textbook again, right? So let's just check that. Sine negative cos. The derivative of negative cos, well, let's see here. Go to our chart there. The derivative of positive cos is positive sine. So negative cos would be negative sine. All right? And seeing as the antiderivative of sine before was negative cos, the antiderivative of negative sine would be positive cos. And so we simply fill in these 4 rows in our DI chart. Okay, so that's the first couple steps here. Again, choosing which one's which, and then filling in the chart to as many rows as you get to 0 here if you have an algebraic term. Now, there's going to be tougher questions where there'll be 2 other parts, I guess, to this technique, which I might go over in a different lesson. But so far, this is all we're running into, so we run into a 0 each time. That's great. So now what we do, if you remember, the diagonal line, and we multiply on the diagonal here, and you see we're going to have at least 3 terms here for our answer, which is a real simplification of the process. Okay? So the answer is going to be this: positive x squared times negative cos x. So it's going to be negative x squared cos x. And then we've got a negative times a negative, so that's plus 2x sine x. Right? And then plus 2 cos x. So I'll just get rid of this here. Plus 2 cos x. Okay? And plus c, and that should be your answer. for the formula, or for the expression, I should say, for the integral of this right here. So now, I think this is in your textbook. Let's just see. Is this in your textbook, or did I just pull this out of my brain? That's where I got this from. Okay. Do you see it in your textbook there, or in your notebook? I don't think so. Okay. So we'll do some more examples from the textbook, but this should be, that should be your answer there for that one. So let me just double check. Yeah. Okay. So that's good. Questions?